Hi everyone, today we're going to be doing the gas law lab, which is part of the Sierra College Physics Department. The setup in front of you shows a large bulb with a fixed amount of gas submerged in a vat of boiling water. We were able to measure the pressure and temperature inside that bulb and take those measurements. So it is suspended in a boiling water, and that is nearly filled to the top, and that is to build some type of thermal mass. We're going to be starting this at a high temperature of say around 80 degrees Celsius, and that temperature is achieved by pouring in boiling water from small boilers. We take the measurement, measuring both pressure and temperature. We'll come back, add some colder water to this, and reduce that temperature by about 3 degrees Celsius. By having so much water in there, that builds a thermal mass, because if I bring the temperature down too quickly, I won't have enough data points to go through my entire set. So to accomplish this, we'll release a little bit of the water out of this coffee urn so we don't overflow. Once that's been done, I'm going to add some cooler tap water to it. And stir around. I'm trying to evenly distribute the temperature around and use that thermal mass to my advantage. I'm going to click Keep Sample. So now we're going to move over to the computer part of this lab. And you can see on the screen in front of you, this is the Pasco setup for what we call the Absolute Zero Lab. There is a graph of absolute pressure versus temperature, and on the bottom is a data set of the temperature on the left and pressure on the right. So I started this data at 79.5 degrees C and 104.4 kilopascals. I added a little bit of cool water, waited for the measurements to stabilize, because if you add cool water in and immediately take a sample, it is not going to have time for the pressure to stabilize, and it'll give you a false reading. So you add in a little bit of cool water, wait till there's no fluctuation in these measurements, and then click Keep Sample. I drained a little bit of water, added some more, dropped it about 3 degrees Celsius, and measured the pressure again. I'm going to keep going back and forth until I get about 15 samples, 15 points. There will reach a point in which you are no longer able to cool this down just by tap water. Tap water here is approximately, say, 23 degrees Celsius. And at that point, I have to take it and measure and add in ice. Be careful when adding in ice, that can drop the temperature too fast. And again, that is why we keep all that thermal mass in there, to help prevent that temperature from dropping too quickly. Now if we look to our graph has 3 points on it so far, or 4 points, and it is giving me a linear line. That linear line has slope and intercept. We do not care about the intercept here. We're actually caring where it intercepts the x-axis. We are going to project that line down to zero pressure and therefore determine where absolute zero would be. So after 15 of these measurements, you're going to use your slope and your intercept to determine where this would extrapolate down to on the x-axis. That should approximately be minus 273.15 degrees Celsius. Please take into your measurements and how these are taken. And again, this is for the gas law lab. Thank you for your time. Have a great lab.